We'll start out the proof by noticing that 2 squared is equal to 2 plus 2. Or we're adding 2 to itself for a total of 2 times. This pattern is true for other numbers. When we have 3 squared, that's the same as adding 3 to itself for a total of 3 times. Similarly, 4 squared is equal to 4 added to itself for a total of 4 times. In general, x squared is equal to x added to itself for a total of x times. This is the equation that will be the basis for our paradox. We'll start out with x squared is equal to x added to itself for a total of x times. Now we're going to use some calculus. We're going to take the derivative of each side. The derivative of x squared is equal to 2x. On the right-hand side, the derivative of x is equal to 1. The derivative of x again is equal to 1, and then we keep adding this, so each time we add a 1 to the derivative of x, and we do this for a total of x times. If we add 1 to itself a total of x times, we find that 2x is equal to x, and this is a problem because this has to be true for every value of x. So it doesn't matter if we put x equals 1, x equals half, we end up with the result that 2 is equal to 1, and this is strange because it seems like every step we've done has been valid, but we've come to a contradictory result. So can you figure it out? I bet if you pose this to your math teacher many times, your math teacher won't know exactly where the proof went wrong. But I'm going to show it to you so that can explain to your teacher why this proof is incorrect. The beginning equation is correct. X squared is equal to x plus itself a total of x times. When we take the derivative of x squared, we get 2x. That's correct, but the mistake comes at this step when we take the derivative of x added to itself x times. We cannot simply add each term one by taking the derivative, and there's a reason for this. When we add x to itself a total of x times, this is not a simple linear equation. Or we could take the derivative of each term. We really have x times itself, so in order to compute the derivative of x plus x a total of x times, we really have a sum. That's involving x. So in order to take this derivative, we need to use the product rule. So we take the first term times the derivative of the second. So we have x times 1 plus the second term of x times the derivative of the first term x to get 1. When we do it this way, we find that 2x is equal to 2x, and of course this is true. And so there's no paradox at all here. There's no contradiction, so the problem in the proof is you can't simply take the derivative of each term because it's not a simple linear expression, it's an expression of x that involves a total of x times. Did you figure it out?